Hi everyone, this is Dr. V. Nirmala, Assistant Professor in Mathematics, Faculty of Engineering, Karpuram Academy Higher Education. In the last video, we discussed about some basic concept of mathematics. In this video, we are going to discuss about probability. Generally, probability means simply likely something to be happen. That means probability simply is called as the possibility of event. Generally, the probability values lies between P of 0 less than x less than 1. Every probability value should be lies between 0 and 1. Generally, probability is concept is based on random events, that is random variables. Random variable is nothing but simply a variable which is the value is unknown. This is called random variable. How it is defined? Suppose I am tossing one coin, the possibility of sample space will be only head or tail. This is the sample space. What I am asking means, suppose I am taking the random variable x, that should be x tends to r. Here x stands for random variable and s stands for sample space and r is specified by range. Okay. So, how to define mine? I am taking the values of like this. Here our sample is only head and tail. So, I am going to consider whenever I am taking the value of h, I am value going to mark as -1, and when I am taking the value of t, that is tail, I am taking is +1. Here the probability is the total numbers is in the sample space is 2, therefore h is 1/2 and t is 1/2. So, here mentioned by this is sample space and this is random variable and this is called probability. Okay. The whole image stands for the range of random variable. Okay. So, how it is defined? Okay, consider the same example h and t. When I am tossing a coin, we are getting only possibility h and t. Okay. Now, we have defined x of 0, that is x of 1, that means x of h, that is what are the possibility of getting h in the sample space is equal to 1. So, similarly, what are the possibility of getting tail in the event is 0, because suppose I am taking only this case mean the value should be 0. So, it can be written as x is equal to 1, the value of h is equal to, that is when x is heads. Okay. Suppose 0 when otherwise nothing but we are not getting the head tails. Let us consider one more example. Suppose a pair of unbiased dice rolled, then x denotes total of score of 2 dice. Write down. We have to solve, we have to find the sample space, the values taken by the random variable x, and inverse image of w, and the number of elements in the inverse image. Now, we have defined our sample space for 2 dice is thrown. 2 dice mean one die mean he has 6 spaces, 1, 2, 3, 4, 5, 6. We have to define for 2 dice. You can write one more time again 1, 2, 3, 4, 5, 6. So, our sample space will be just you can define 1 is mapped to all the elements 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, similarly 1, 6. Have to write like this 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, have to proceed for number 2. So, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. Similarly, for 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. For 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, The last one 6-1, 6-2, 6-3, then 6-4, 6-5 and 6-6. So, the number of sample size is totally 6 having. So, 6 and 6 will be sample size is 36. Okay. Now, we have defined the second thing, that we have defined the values of taken by the random variable x. So, how it is defined by, suppose we can consider x of alpha comma beta mean, that is equal to alpha plus beta. So, in this we have defined, first you can consider only 1 1. So, x of 1 comma 1, that is equal to 1 plus 1, that is equal to 2. Okay. Like this you have to, like this way you have to take. So, the second one is 2 comma 1, that is x of 2 comma 1 is equal to x of 1 comma 2. The value is total is 1 plus 2, that is equal to 3. Then the next value is 1 3, again 2 2, 3 1. Here these values. So, x of 3 comma 1 is equal to x of 2 comma 2 is equal to x of 1 comma 3. The value will be 1 plus 3 is equal to 4. Similarly, x of, like this we have to do, we have the value of 1 4, 2 3, then 3 2, then 4 1. That will be x of 1 comma 4 is equal to, and so on, that will be 1 plus 4, that is equal to 5. Similarly, that one the next one, then this is finished. So, 1 4, 1 3 is then 1 5, 2 4, 3 3, 4 2, 5 1. The value will be, simply can write first value. So, 5 comma 1, that is equal to 5 plus 1, that is equal to 6. The next one 1 6, 2 5, 3 4, 4 3, 5 2, 6 1. This will be, you can write first element 1 comma 5, sorry 1 comma 6, that is equal to 1 plus 6, that is equal to 7. The next one 1 comma 6 is finished. So, 2 comma 6, 3 comma 5, 4 comma 4, 5 comma 3, 6 comma 2. So, this will be x of 2 comma 6 etc. is equal to 2 plus 6, that is equal to 8. Then here now 6 3, 4 5, then 5 4. This will be x of 2 comma 6 etc. that is equal to 3. So, 6 plus 3 is equal to 9. Then next one 6 4, 5 5, 6 4. So, x of 4 comma 6 and so on, that is equal to 4 plus 6, that is equal to 10, and this one is 6 5, 5 6. So, 5 6 is equal to x of 6 5 is equal to 6 plus 5 is equal to 11. The last one x of 6 comma 6, that is equal to 6 plus 6, that is equal to 12. So, these are the elements of the values 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we are adding all those things, we will get 36. Okay. Then the next the given inverse image of W. Inverse image of W is nothing but they given some W really here. Suppose we are taking W is equal to 10. Okay. So, what is the inverse image? Inverse in 10 means we have to calculate which value is total is 10 here. So, what are the possibilities here? So, 6 comma 4 is adding value is 10, then 4 6 value is 10 and 5 5 is 10. So, you have to write reverse term, that will be, so 6 4 is can be written as x of, or simply can write 6 comma 4, that is reverse, just place is swapping the number place. So, 4 to 6, 6 to 4, so 6 comma 4, then 5 is again same, so 5 comma 5, then 6 comma 4 is like that, 4 comma 6. So, this is the inverse image of the number 10. Suppose they are asking for an inverse image of 4. So, what are the possibility of 4 here? 1 3, 2 2, 3 1. So, we can write, so 1 3 can be written as 3 comma 1, then 2 2 is same, so 2 comma 2 and 3 comma 1 comma 3. So, this is the inverse image of 4. So, likewise, we can find any element of W. Here consider as W is 10, W equal to 10, or W is equal to 4, like this we have. So, what are the possibility we reached? So, sample size, the sample value is 36 and we define the value of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are the elements of the given sample space, and the inverse image of 10 is, that is 6, 4, 5, 5, 4, 6. So, this is one example for random variable. Next we are going to deeply discuss about random variable. Random variable is divided by two parts, that is random variable. One is discrete case and second one is continuous case. Simply you can say, suppose sample size is countable, that is called a discrete case. Suppose uncountable mean the case is called discontinuous, that is continuous. Countable means uncountable is called continuous. Okay, that is discrete means countable, continuous means uncountable. Okay. So, in this we are going to discuss about first discrete case. So, okay, discrete case is nothing but in this we are going to find probability mass function. Okay. So, in this case we have defined x of xk or f of xk is equal to p of x is equal to xk. This is the formula for probability mass function in the random variable for discrete case. For example, suppose we are tossing a coin, we get sample space x is equal to either h or tail. This is only one time. Suppose I am tossing a coin simultaneously, two coins or two times a single coin, we get, what are the possibilities? The sample space will be HH, TT, HT and TH. So, this is the possibility of a coin tossing two times, a single coin tossing two times. Okay. In this, what I am going to find the PDF, that is PDF or PMF is nothing but probability mass function. I am going to consider the probability of getting head in sample space. Okay. So, sample space. So, what are the possibility of head here? In this case, we having head, there is no head, here head and head. So, we have to consider the probability of which of the sample space having the heads. Okay. So, that will be, so x of, that is random variable of t comma t, our constraint should be having head. Here there is no head, therefore that is 0, and x of t comma h. In this case we having only one h, so probability 1, and x of ht, in this case also having one head, therefore that is equal to 1, and h of h comma h, that is we having two head, so you can write this is the random variable of the given sample space. Now we have defined the value of function, that is mass function. So, just can take f of 0, f of 0 is nothing but p of x is equal to 0. So, how many cases we are getting 0? We have 4 values 0, 1, 1, 2. So, here having 1, this 0 case is 1, therefore, that is equal to 1, but we having the probability, the total sample space is 1, 2, 3, 4. So, this will be 1 by 4 and f of 1. So, how many times we are getting 1? When that is here p of x comma h comma t we are getting 1 and x of t comma h also getting 1, that we having 2. So, 1 by 4, that is yes. So, 1 plus 1 by 4, that is equal to 2 by 4, that is equal to 1 by 2. So, for f of 1 we are getting value 2 by 4 is equal to 1 by 2, and that is f of 2. F of 2 means p of x is equal to 2. We having only one case, here only h comma h, that is we are getting 2. Therefore, this will be, so it is 1 by 4. So, that will be, this is the value of, for f of 0 the value is 1 by 4, f of 1 the value should be 1 by 2, and f of 2 the value is 1 by 4. So, whenever you consider the value the given case is discrete, all the f of x value should be greater than 0. First we have to check. So, f of 0 greater than 0 positive, f of 1 greater than 0 positive, f of 2 greater than 0 positive. So, this condition is satisfied, and one more condition, summation k xk, that should be equal to 1. Okay, that is our f of xk this should be equal to 1. So what is the value here? Our f of sk is nothing but the addition of f of 0, f of 1, f of 2 should be equal to 1. So what is the value? That is f of 0 plus f of 1 plus f of 2 is equal to 1. That is f of 0 value is 1 by 4, f of 1 is 1 by 2 and this will be 1 by 4. So I am taking 4 as an LCM, therefore 1 plus 2 plus 1, 4 by 4, that is equal to 1. Hence the discrete case is satisfy the condition f of x is greater than 0 and summation k xk is equal to 1. This is the example for the discrete case. Let us consider one more example in discrete case. A random variable x has the following mass function. X values are 1, 2, 3, 4, 5, 6 and f of x value will be k, 2k, 6k, 5k, 6k and 10k. We have to define the condition 1 p of 2 less than x less than 6. Second condition p of 2 less than or equal to x less than 5 and third one p of x less than or equal to 4. Okay, so let us consider the given values are x is 1, 2, 3, 4, 5, 6 and f of x is given by k, 2k, 6k, 5k, 6k and 10k. We are going to define the first value p of 2 less than x less than 6 and second one p of 2 less than or equal to x less than 5 and the third one p of x is less than or equal to 4. Okay. So, whenever in a discrete case our value should be all the f of x should be greater than 0. The second value summation k f of xk should be equal to 1 because we do not know the value of k here, the k value is unknown. So, first we have to define the value of k. So, how we will get k? Just you can add all these values that should be equal to 1 because our condition. So, k plus 2k plus 6k plus 5k plus 6k plus 10k is equal to 1. So, this value will be 1 plus 2 3, 3 plus 6 9, 9 plus 5 14, then 14 plus 20 30. So, 30 k is equal to 1, therefore, k is equal to 1 by 30. So, now we know the value of k, then our given table column will be x values, that is k mean simply you can write 1 by 30, this will be 2 by 30, this will be 6 by 30, this will be 5 by 30 and this will be 6 by 30, this will be 10 by 30. So, now we know the value of f of 1, that will be 1 by 30, f of 2 means 2 by 30, f of 3 means 6 by 30, similarly 5 by 30, 6 by 30 and 10 by 30. Okay. Now, we have to calculate the value of p of 2 less than x less than 6. So, what is the meaning of this one? The x value should be less than 6 and less than 2. Okay. Here these are the values of 1 to 6, the values of x here. So, now that should be, we should not be take 2 and 6 because they given only less than not equal. So, you can simply consider 3, 4, 5. Okay, that is equal to p of x equal to 3 plus p of x is equal to 4, then plus p of x is equal to 5 because we are considering only 2 less than x less than 6. We know the value of x equal to 3, therefore f of x value x equal to 3 will be 6 by 30 and this will be for x equal to 4 5 by 30, this will be 6 by 30, therefore 6 plus 12 plus 5 17, therefore 17 by 30, therefore probability of 2 less than x less than 6 will be 17 by 30. Similarly, we have defined p of 2 less than or equal to x less than 5. Okay, less than 5 means we have to consider only less than 5, that will be we have to omit the value of 5, rest of the value should be up to 2. So, 4 possible, 3 possible, 2 possible because they given less than or equal to here. So, what is the value here? We have to consider only p of x is equal to 2 plus p of x is equal to 3 and P of x is equal to 4. You no need to take the value of 5 because they given only less than 5. Now you can take the value and add it. P of x equal to 2 will be, that is 2 by 30, then 3 6 by 30, then 4 5 by 30. Now you can add it. So 6 plus 2 8, 8 plus 5 13, so 13 by 30. This is the probability of 2 less than or equal to x less than 5. The last value they given x is less than or equal to 4. X is less than or equal to 4. So what is that? X should be less than or equal to 4. Okay. So what is less than or equal to 4? X value is 1, 2, 3, 4, 5, 6. So less than or equal to 4 means less than or equal. So that may be up to 1, 2, 3, 4. So this will be P of x is equal to 1 plus P of x is equal to 2, P of x is equal to 3 plus P of x is equal to 4. So now we can add all these values. 1 by 30, 2 by 30, then 6 by 30, then 5 by 30. So now we can add it. 1 plus 2, 3, 3 plus 6, 9, 9 plus 5, 14. So 14 by 30. So this is the probability of the discrete case, the given problem. X is equal to 1, 2, 3, 4, 5, 6 and the value of k is when unknown. Okay. In this video we discuss about what is probability and the value between probability will be 0 and 1. And one more thing we have discussed about what is the application of probability. The probability is applied in statistics, census area, sports and weather forecasting management. Thanks for watching.